All right, now we're going to do examples with more than one variable. So now the variable is going to matter. So for this first one, I have my coefficients, my 5 times my 10. So if we're doing mental math, that's what I'd be doing, 5 times 10. Now, this is not what I'm not going to do. So this is wrong. I'm not going to go 2 plus 3 is 5, plus 5 is 10, plus 2 is 12, and write 50xy to the 12th. That is incorrect. Okay, because if you look at that, the 12 is on the y. So what this is saying is you've got 50, then you have 1x and 12 y's is what that's saying. But that's not true. I have 2 x's here, 5 x's there. I can't just say in the end I only have 1 because there's still that invisible 1 right there. So you have to be very careful. So we're only going to put x's with x's and y's with y's for the exponents. Okay, strictly talking the exponents, not the coefficients like with adding and subtracting. So that's where it gets tricky. You really have to separate adding and subtracting from multiplying in your mind. You have to get those separate. So what I'm going to do is I'm going to say there's 2 x's represented right there, 5 x's represented right there. So we'll total those up in a minute. 3 y's represented right there, 2 y's represented right there. So I'm kind of writing out what you would do in your mental math. So 5 times 10 is 50. I have a total of 7 x's being multiplied together. X times X times X times X times X times X times X. Then I've got a total of 5. I don't know why I wrote that multiplication. That is so not needed. Y to the 5th. And what I did right there is actually kind of a good point. You don't need multiplication between these. It's already implied. So in your final answer, there will be no times signs. There will be no parentheses. It will all be one chunk monomial. Okay. So this one over here, coefficients, I have the 9 times the 3. Then I have an x here and x to the 3rd there. Now for this one, this term does not have a y, but this one does. So I'm only going to have that one y represented in the whole monomial, which is okay. That's perfectly fine. So 9 times 3 is 27. Don't forget that's an implied x to the 1st, so that's going to make that x to the 4th. And then the one y that was represented in the entire problem just gets put at the end. I like to keep these in alphabetical order, which is how you're going to see most of these problems written out. You'll very rarely not see it in alphabetical order. So moving on to number 7 here, we have our coefficient -4 times, this is an implied -1, so when you're doing your mental math, just be very careful with that for me. I've got m to the 7th and m squared, so we're seeing other variables besides just x and y. Then I've got p squared and p to the 4th. So -4 times -1 is going to flip that to a +4. That's what I'm talking about here. Just be careful. Those two negatives being multiplied will cancel out and make a positive, only with multiplication and division. I have a total of 9 m's being represented and a total of 6 p's being represented for my final answer, my final monomial. So for number 8, now I have 3 terms, getting a little bit harder. So I have the coefficient of 6 times a coefficient of -3 times technically a coefficient of 1. So we'll go ahead and write that. It will never hurt to do that, especially like I said, if it's a -1, you have to. Then we've got x squared, and x to the 3rd, and I'm running out of room. I always write too big. That's okay. Then I have y to the 4th, y to the 2nd, and another y to the 4th. All right. 6 times -3 is -18 times 1 just leaves that -18. Then don't forget the implied 1. So 1 plus 2 plus 3. So I have a total of 6 x's being represented. 1 plus 2 is 3, plus another 3 is 6. Then the y's, I have a total of 10. 4 plus 2 is 6, plus another 4 is 10 y's being multiplied together for my final monomial.